Hello everyone, hope you all are doing well. Pardon, but I still have a cold. We are about 30 subscribers away from 8,000. Appreciate that. Hope y'all are doing well. This is 3D Printed Creature, part 17, Building the Blink Mech. We're going to start building this animatronic. Building this animatronic, I would say the hardest part would be building the Blink Mech. And when I say being hard to do, it's just small linkages and setting up two servos on one channel. And these two servos are mirrored, so we're going to have to use a Y cable and a reverser. Having a new printer, I'm having to drill out these holes. They're a little on the small side, but I'm placing 3mm screws in these holes here, and 2mm for the servo sockets. And in the world of 3D printing, when we have a new printer, we're always searching for the right profile. This eye plate was probably the main piece. This is what I originally started designing from. Designing the eyelids and eyes. These are the servos that we're going to be using for this animatronic. Now these what they call JX servos, and this is a PDI 1109 MG. MG stands for Metal Gear. Now they got pretty good torque, and it's usually I believe it's 2.5 kg, and that's pretty strong for this little servo. And this servo comes with an assortment of servo horns and some mounting screws and a main screw to screw the servo horn in place. The eyes on this animatronic are black beads. And I started using beads a long time ago because, black, there's a lot of animals and creatures that have black eyes. So I just developed some eyelids around it and printed them. Next thing you know it, I have a blink mech with some black eyes. But these beads come in different sizes. I've seen them as small as 6mm, and they go all the way up to 30mm. Now this one here is a 22mm. Well, I'm just trying to make sure that everything is going to be available for my Patreons when I have it set up. But you can see some of these sizes of these beads. And if you really want to get into animatronics, order you some of these beads and just start tinkering around with them. And I'll probably have some eyelids available as far as STL files. And when you get a set of eyelids, you can enlarge it or shrink it down to the size you need to fit that bead. A servo has a rotational shaft. It's like a motor, and there's a gearbox. In the gearbox are metal gears. Well, they need to be mounted aiming towards the back of the eye. That way it makes the linkage smaller. You will probably see me post this picture here a few times in this video. It's just a demonstration of like an instructional guide on how everything should be placed as far as the linkage and even the direction of the servos. Also for this animatronic, I purchased a set of screws which are 2, 3, and 4mm, and they also come with nuts and lock washers and washers. Also, I'm using threaded rods, and there's some 2mm rods and 3mm rods I'll be using. But it's just, this is the building part, and I kind of designed, and some of the holes that I made in the design were for certain size rods. So I'm placing these small 2mm screws with nuts in the servo socket to lock the servo in place. I have some of those nylon lock nuts coming, but they're not arrived yet. But I would put these regular nuts on there first because, once again, I may have to take things apart. But overall, everything is basically is putting it together like a model airplane or a model car. Now it's time to install the eyelids in the eyeball. Now, as far as the eyelids, there's a top eyelid and there's a bottom eyelid. And the top one kind of covers the lower eyelid. And I'm talking about the eyelet, or where the hinge mechanism goes. As you see here, you will see the ends where it's actually covering the lower eyelid. I don't like supports because they kind of mess up the finish of a 3D print, but we have to have them, and sometimes you just have to do it. But once again, it's probably a big difference between a $250 printer and a $1,000 printer. Now, I've done this process a lot. In designing these animatronics, I've come across, and sometimes it can be tedious. Now, this is the tedious part. Now, when I slide this rod out, it's going to be, I'm holding it in place. So I got to thread this rod through the support and then through the two eyelets right there, and then go through the ball and then through the other side. Now, this is part of it, but it will work, and it's just tedious. Now, this is the hardest part of the whole animatronic. But the one thing is that sometimes that black bead, you can't see the hole that's in the bead, and there's a 2 millimeter hole that you're having to go through. And that's why I use that first rod as a guide, and that helps me pass it straight through. Once again, more likely it's going to slip, or you'll bump it and it'll all come apart and you have to start over. But eventually you'll get it. Now, this threaded rod is a 256, and that is a 256 nylon lock nut. So, I mean, I'm going to have all these so-called listed in the Patreon on, what parts and hardware, just listing everything. But you just have to keep spinning it. Now that lock nut is also just there to hold everything in place. I have some more coming, and being so small, some of them are kind of hard to find. But um, I I think I found these on Amazon. But once again, I'm trying to make everything uh, metric instead of having two different, like imperial and metric. And I'm in a small town in Louisiana, and metric is kind of rare. I mean, you can find them in the big box hardware stores, but it's still imperial, but I really prefer metric. And here's a perfect example of what I'm talking about. You'll get it just right there, and it'll fall apart. Try again, and eventually you'll get it. And then it's time to set up the servos. And this is the importance of having an RC radio and doing any kind of animatronic. And most animatronics in the movie industry is using radios. And they call them puppeteers because they have as many as up to 6, 7 people working radios. But here's the receiver, and this is, you have 7 slots, but it's a 6-channel receiver. And one of the channels is for the power, and that's the battery. And then this wire here is an on-off switch, and it goes to that seventh channel, which is just for power. And then you just plug up the battery, and it's on the off position. And when you turn on a radio, you turn on the radio unit first, and then you turn on the receiver. And then to shut down, you turn off the receiver first and then the radio. But with the advancements of radios, they kind of give you warnings or alarms telling you, are you sure you want to do that? But in the old RC radios, before all the digital stuff came out, if you turned off the radio, your servos would go crazy, and they would actually even break some of your linkages. But I want to help everybody because some people have no what to do. They want to build animatronics and just don't know how to get into it. So I'm just trying to help everyone on how to learn this, and most of y'all probably know how to do this. But as far as setting up the servo itself, I'm going to plug in one of the servos, and I'm going to power up my radio and turn on the receiver with a servo plugged into the number one channel. And when I turn it on, that arm will move. And sometimes it won't move, but it just moved barely here. But this is called centering the servo, because the servo has a center. It moves left and right or up and down, but it's a rotational. And when you turn that power on, it's automatically going to go to center. There's a few servo horns in the package that they give you, and it's usually a single long servo arm, and it has anywhere from 3 to 4 holes in it. Well, I go to the second from the top hole, and I drill a 2mm hole there for my so-called screw, and I do a hole in the other servo horn also. You have a linkage for each eyelid. The top eyelid is shorter linkage than the lower, and they're all joined at that screw point on the servo arm. So by looking at my design, I laid the top servo linkage on top of the servo arm, and then the lower linkage to the eyelid laid on the back of the servo arm. Then I placed a screw through all three: the top linkage, the servo arm, and then the lower linkage. And this is all for the servo arm. So now I connect the lower linkage to the lower eyelid with a 2mm screw and nut. And to help this process, I'll take some glue stick and I'll put it on the end of my instrument like a flathead screwdriver, and I'll hold that nut in place. I will also apply some glue stick glue to the threads. This way it will prevent the nut from backing out. Then I repeat the process with the upper linkage. Connect the upper linkage to the upper eyelid with a 2mm screw and secure it with a nut. But I've used all kind of stats and tweezers and all kind, but most time it's just a flathead screwdriver with a little glue on the end of it to help me support it while I get the nut threaded. Like I said before, this is the tedious part of building this animatronic. And anything with eyelids, it's going to be tedious like this because it's going to be very small parts. After I connect both linkages to the eyelids, then I can connect the servo horn to the servo. I turn on the radio and I turn on the receiver and I do the first test movement. And if there's any adjustments, if it's not closing all the way or it's too tight, I can move the servo arm in a different location onto that rotating shaft. And as you see here, we have one eyelid blinking. And now it's time to repeat the process for the other eye. After getting the linkage set up for this other eye and eyelids, what I have to do is set up a single channel for two servos, even though the servos are mirrored, just to demonstrate with this another horn that I'm using, as you see here. When I have a Y cable on one channel and I'm going to make it rotate the eyelid, you'll see the other servo horn going the opposite way. And to fix this motion, we need to add a servo reverser to this servo. Now, since we have the motion corrected, now we can connect the servo arm that has connected to the eyelids. We can connect the horn to the shaft, and now we can get both eyelids blinking. We have two mirrored servos connected to one channel with a reverser and a Y cable to produce this blink. We should be able to put this thing together quick. So what do y'all think? Well, hey, I appreciate y'all. Thanks a lot. Thanks for the shares and comments, likes, and the new subscribers. Y'all have a great day. Later.